We're now into exercise 6.7 question 8, which is also a heat pump system question. Now from reading carefully through this question, we can establish what we know, and immediately we can see that the coefficient of performance of the question is 3.5. So we can write down that COP equals 3.5. We're also told in the question that the heat pump uses up 5.0 megajoules of energy in 1 hour. And of course the type of energy that is more technically transferred into other forms by the heat pump is indeed electrical. And so W equals 5.0 megajoules per hour. Now we've come across inside the textbook so far kilo, and kilo represents 10 to the power 3. The next prefix is mega, which represents 10 to the power 6. But we won't need to utilize that in this particular question. It's just in case you're wondering what that capital M in fact represents. Now we're asked to work out or to calculate the amount of heat energy that this heat pump will produce in 1 hour. And so effectively we're asked to work out, well, what is the value of QH? And so we can write down then QH equals question mark. But it is QH in 1 hour. And that's important, as we'll see at the end of this question. The equation to work out COP is quite simply QH divided by W. Now to get a value for QH, we're going to have to eliminate W from the right hand side of the equation. And to do so, we will need to multiply both sides of the equation by W. And so the equation then becomes COP multiplied by W equals QH multiplied by W all divided by W. Now any number divided by itself gives 1, and so the two W's will in fact cancel out. And the equation then becomes QH equals COP multiplied by W. And that gives us 3.5 multiplied by 5 megajoules per hour. And so the value of QH then will be 17.5 megajoules per hour. The question really does ask us, well, what is the exact amount of energy in 1 hour? And of course QH therefore is 17.5 megajoules. There's no need for a respective time here. The question asks us for the energy transferred in 1 hour, and 17.5 megajoules is that quantity of energy.